Good morning, everyone. A warm welcome to all present in this meeting. On behalf of the Department of Mathematics at Wilson College, Autonomous Mumbai, I heartily welcome Lieutenant Prakash Sansare, sir, for his first session in this IIT JAM Mathematics lecture series organized under the DBT Star Strengthening Scheme. Sir is the head and assistant professor at the Department of Mathematics of B.K. Birla College, Kalyan, India. His areas of interest are in real analysis and partial differential equation. Sir will be conducting sessions on functions of one variable in this series. Sir, thank you for graciously accepting our invitation. We are really grateful to have you today with us. Over to you, sir. Thank you.
Yeah, now can you hear me?
Yes, yes.
Yeah, okay.
Yeah,
So let
we
me
will.
share my screen. Thank you so much. So thank you so much. Uh, maybe I have been given a topic from L hospital rule to fundamental theorem of calculus, and I'll be taking first fundamental theorem of calculus. So there are two famous fundamental theorem of calculus, which we will be covering in this lecture. Not theorem as such. We'll be doing the statement of theorem and we'll see a problem based on it. And the applications, basically the application of this theorem. Uh, so before starting with this first fundamental theorem of calculus, I'm sure that the audience must be aware of what is continuity and differentiability. Assuming that, I'll start with the first fundamental theorem of calculus. So here is a statement of first fundamental theorem of calculus, uh, which says that if you have a function which is continuous, defined on a closed interval a comma b, and this f of x, capital F of x, is basically integration a to x f of t dt. So this is also called as a indefinite integral. Then it says that your capital F is differentiable. Further, it also gives a relation between uh, capital F and small f, that is f dash x is equal to f of x. So it's a interpretation is differentiation and integrations are inverse in process. This is what the interpretation of first fundamental theorem of integral calculus says. Right. So what you required for first fundamental theorem of integral calculus, number one, you should have f should be continuous, and second, you should have a indefinite integral of f. So that is basically f of x, which is equal to integral a to x. So here f of t dt. So if these two things are, if you have these two things, then you can straight away say this indefinite integral is differentiable. Moreover, the derivative of this indefinite integral f dash x is basically f of x, small f of x. So how do I know whether participants are really means? mm, do I have a chart here? So does the participant have chat option? I mean, have they given a
So they can
permission for
unmute
chat here?
themselves. They can unmute themselves and speak.
Okay, okay, okay. They can unmute and they can speak. But then I just wanted to know through our reactions, maybe there are many emojis here. So whether you have, are you getting what I'm saying? Just wanted to know, participant, somebody.
Yes, sir, go ahead.
Okay, thank you. Thank you so much. So so using these two theorems, there are in the IIT JAM exams. many a times the questions were asked on the first fundamental theorem of integral calculus. So we'll see what kind of examples are exactly asked. And with aligned to this, we will also solve the problem which will have a direct applications of the first fundamental theorem of integral calculus. So now here, what are the first one is it's very useful for computing derivative of integral functions with variable limits. And this is Leibniz rules. It's basically derived from the first fundamental theorem of integral calculus only. So this has a very simple proof. So maybe I'll give a hint of the proof of this. So what the Leibniz rule says, this is powerful result, which says that if you have an indefinite integral and gx and hx f of t dt, of course here I should mention that h and g are differentiable. Then it says that your f dash x is equal to f evaluated at hx into h dash x minus f evaluated gx g dash x. So f evaluated at upper limit into derivative of upper limit, then f evaluated at lower limit gx, and then derivative of g of x. So how do I prove this? It's a very small proof it has. I'll just give a hint to prove. So before proving this, I will be proving the form. So if okay. So suppose I have a function fx, which is, or maybe I'll say some other name, hx, which is equal to integral a to some g of x f of t dt. Then if somebody asks me what is derivative of this h dash x, then how will I calculate this? The answer to this is very clear. I'll say you first have the indefinite derivative of f of t. So f of x is an indefinite derivative a to x f of t dt. And since this f is continuous, so by first fundamental theorem of integral calculus, first fundamental theorem of integral calculus FFITC, my f dash x is equal to f of t, right? Now, my question is to find h dash x. So how will I calculate h dash x? Now you could see that my f at g of x from this f at g of x is equal to basically a to g of x. So instead of x, I supposed to put f of x, a to g of x, f of t dt. And this is my basically h of x, because here h of x is basically, right? So what I got is f of g of x is basically h of x, and I need to find out h dash x. So my h dash x is basically, by chain rule, it will be f dash g of x into g dash x. And what is my f dash x? I already know my f dash x. I should say here f of x, it was mistake. So it is f of x. My f dash x is, f dash is my f. So it is basically f of g of x into g dash x. So what I got, h dash x is basically f of g of x into g dash x. So if I, so it's very clear that if my h of x is of this form, then my h dash x is straight away f of g of x into g dash x. Right. Now you observe this function f of x in terms of indefinite. You can now this small proof will help out to complete this proof. Now my capital F of x can be written as integral g of x into a times f of t plus I can add a in between. So this is basically, I'm assuming that students are aware that a linearity property of Riemann integration. So here f of t dt, and then apply the this result, this h dash x is equal to this on this as well as this, you'll get this required result. So f dash x is equal to f of h of x into h dash x, f into g of x into g dash x. So this is also called as a Leibniz rule. So this is a small exercise, one can work out and easily get it. It's not difficult. So what we got, this is very powerful result. So what we got, if f of x is equal to g of x into h of x, then f dash x is equal to f of h of x into h dash x minus f of g of x into g dash x. Okay. So let's go for the problem solving session. So the first problem, basic application of first fundamental theorem of integral calculus. If I have my f of x is equal to this, fx is equal to sine of integral 0 to x sine of t square, then the question is find f dash x. Okay, so my question is, first question, what is f of t here? Small f of t.
Sin t square.
Very good. It's sine t square. Right. So f of x is basically indefinite integral of sine t square. Now I can apply the first fundamental theorem of integral calculus, provided it should satisfy the two conditions. First should be f should be continuous, and second, this is an indefinite integral straight away. F of x is an indefinite integral of sine t square. So that's okay. So second, I need not have to worry. So the question is f continuous?
Yes, sir.
Yeah, why? Yeah, so it's a continuous because being a trigonometric function, it's a continuous. One can also see a graph of sine. If you draw, there are ways to check the continuity. One of the ways to check the using epsilon delta, you can check the continuity, and the second way, draw a graph of the function. If you do not find any break in the graph, implies that the function is continuous. Okay, so geometrically also one can see, and using epsilon delta, this is a standard function. So being a trigonometric function, it's a sine t square is a trigonometric function, so it's a continuous. So by first fundamental theorem of integral calculus, my f of x will be straight away f of f dash x will be f of x. So f of t is sine t square, so it will be sine x square. Is it okay? Just a one line answer by first fundamental theorem of calculus. First fundamental theorem of integral calculus. So the derivative of this function is if f of x is equal to sine t square 0 to x, then its derivative is straight away sine x square. Okay. So maybe I have also solved here. This final answer. So what if I have a limit as a variable here x and x square? Okay, so can you recall that Leibniz rule which I have stated? If I have f of x is equal to some integral hx gx, and here it is f of t dt. So if f is continuous, if this function is continuous, this g is differentiable, this h is differentiable. If this is happening, then we can straight away say that then f dash x is equal to f of g of x, f evaluated at upper limit into g dash x minus f evaluated at h of x into h dash x. This is okay. I just repeated the Leibniz rule here again. So now can you tell me, so instead of f, I have a g now. So maybe we can use any. So let me write down here g, capital G. So then here I wrote capital G dash x is equal to this. Okay, so by comparing this, can you tell me what is my f of t here?
E raised to the power t square.
Very good. What is my h of x?
X. X and g of x is
Small
x
g
square.
of x is x square. So I need to check whether f is continuous. Is e to the power t square continuous? Yeah, it's a exponential function. These are the trigonometric, exponential, algebraic, constant. They all are the standard functions. So they are by default continuous. So it is continuous. Then x and x square, they are algebraic function. So they are differentiable. So this basic hypothesis, continuity and differentiability of small f and this h and g is getting satisfied. So then I can definitely apply the uh, Leibniz rule. Leibniz rule, or you can say that basically first fundamental theorem of integral calculus only. By first fundamental theorem of integral calculus, it says that g dash x is equal to f evaluated at upper limit g of x into g dash x minus f evaluated at h of x into h dash x. So here, so f at g of x, my g of x is x square, so f at x square into g dash x. So gx is x square, so g dash x will be 2x minus f evaluated at hx. Hx is x only, and h dash x, x ka derivative is y. So which is same as f of x square. So f of t, I know it is t square. So what will be the f of x square? So it will be e of x square ka square into 2x minus f of x. F of t is e to the power t square. So e power x square, which is same as, now this is e power x power 4. So exponent get multiplied and this 2x will come ahead. 2x minus e of x square. So I got finally my g dash x as 2 times x e power x power 4 minus e into x square, ex. So maybe, yeah, you can see here using rule of variable limits. So f of, so uv, so this is basically g, this is basically h, that doesn't matter. So maybe here u of x is equal to x, it is x square, f of t is t square. So I have used the Leibniz rule here and we got this answer. Is this okay?
Yes, sir.
Okay, good. Yeah, this is a question which asked in the 2015. If f of x is equal to 0 to x, x minus t sine t dt, find f double dash. Okay, so let's solve this. So f of x is equal to here into the 0 to x. So I can multiply this inside. So x sine t minus t sine t. Well, this is continuous. This x minus t is a polynomial, sine t is trigonometric. So both are the continuous function, and we know the algebra of continuity. So if two functions are continuous, the product has to be continuous. So this x minus t into sine t is continuous. Well, they are also they are Riemann integrable also. So we can definitely distribute this integral inside. So if I take this integration inside, this will be 0 to x sine t dt minus integration 0 to x e sine t dt. Now here I am integrating with respect to t, so that should be remembered. So here the parameter, so when I am integrating with respect to t, this x is a constant. So I may take this x outside. So this is integration 0 to x sine t dt minus integration 0 to x. Now here t sine t. Now I got this f of x is this. Now the question is find out f double dash. So before calculate means to find out f double dash, I need to calculate first f dash and then I'll go for the second derivative. So if I differentiate on both sides, what I'll get, it will be f dash x to left hand side. Now here, this is x, function of x, and the output of this integration, what will be the output of this integration? It will be a function or constant value.
The function of x.
It will be a function of x. Very good. So x into function of x. It's basically product of two functions. So we know how to find out derivative of two functions. I mean product rule we have. So basically I'm going to use UV product rule of derivative. So what is the product rule of derivative? It is basically u into derivative of v plus v into derivative of u. So what I'll do, I'll 0 to x sine t dt, I'll keep as it is. Find out t by dx. I'm derivating with respect to x. So let me write down a differentiate with respect to x. D by dx of x plus x times find out derivative of d by dx of 0 to x sin t dt. Right? Now minus, what is integration 0 to x t sin t? What will be the derivative of this? I use some other color. What is derivative of this?
A sin x.
It will be can you repeat? I did not listen. Sorry.
X sin x.
Yeah, it will be x sin x because of by
Fundamental theorem of calculus.
first fundamental theorem of integral calculus says that. So zero. This is an indefinite integral, so its derivative basically x sin x. Very good. So now this is same as integration 0 to x sin t dt. So derivative of x is 1. So, and this is x times. Now again, this integration is as already, what is integration of this? 0 to x sin t dt. So it is basically derivative of this. So this is basically again first fundamental theorem of integral calculus. It will be sin x minus x sin x. You could see that this two terms will get cancelled. So you will have f dash x is equal to 0 to x sin t dt. And now this is basically some g of x. So basically you have g of x is equal to 0 to x sin t dt. And now if somebody asks me what is g dash x, then it is straight away by first fundamental theorem of integral calculus, this will be what it will be, derivative of this.
Sin x.
Yeah, it will be sin x. So g dash x, but gx is basically f dash x. So derivative of g dash x means f double derivative. So this is basically f double derivative of x is equal to sin x. I hope it is clear. Okay, if you have any doubt, I'll wait for a minute, and if there is any question, I'll take it and then we'll go ahead. Okay, so now here is another question which was asked in 2018. If f of x is equal to integral 0 to x minus t equals to minus t dt, find f double dash x. Now instead of capital F, you have a small f. So I'll wait for some time and I'm sure that you will able to solve this. So it's 11:35, 11:36 in my watch now. So I'll wait for 2 minutes. Let's see whether you can able to answer or not. Yeah. So anybody? Okay. So it goes on a similar line. So you could see that f of x is basically, I can distribute this 0 to x e power minus t minus integration 0 to x t times e power minus t. In fact, when I'm integrating, just, this is basically dt minus integration 0 to x t times e raised to minus t dt. And since I'm integrating with respect to t, so this x I can take outside also. It is independent of this t. So you may take this t. And now you differentiate once. So this will be f dash x. So here, now differentiating with respect to x, that's very important. With respect to x. So when I'm differentiating with respect to x, I'll get f dash x here. Now here I have, this is x, and the output of this integral is basically a function of x. So I have to use a product rule. So it will be 0 to x e raised to minus t dt into d by dx of x uv rule plus x times d by dx of integration 0 to x e raised to minus t dt, and this is minus. So integration of this basically, derivative of this is basically your first fundamental theorem of integral calculus. It says that x times e raised to minus x. Now this is same as integral 0 to x e raised to minus t dt. Now derivative of x is 1, so plus. Now this is x. This derivative and integration get cancelled. So basically they are, this first fundamental theorems basically says that they are inverses of each other. So it will get cancelled and you will have e to the power minus t. So instead of t, you have to take in a function of x, you have to write. So e raised to minus x. Minus x times e raised to minus x. And the similar terms get cancelled. Yeah. You could see that this you can cancel out, which is same as, so 0 to x e raised to minus t dt. So this is my f dash x. And what will be my f double dash x? So f double dash x will be the derivative of this basically. Again differentiate this with respect to x. So e raised to minus t dt. And this integration derivative again will get cancelled and you will left with e to the power minus x. So you will have f double dash x is equal to e power minus x. This is your answer. Many a times in exam, the board may ask, instead of this, they may ask, find out f double dash at 1. So that won't be difficult because since you are calculating f double dash, so what will be f double dash at 1? So f double dash at 1. So if it is asked at particular value, you could able to answer that e to the power minus 1 or 1 by e. Or maybe if it is asked f double dash at 0, then you can see that it is 1. So sometimes there are numerical type answers. So where you just have to write the answer. So if f double dash 1 is 1 by e, so this is, or maybe this kind of problems gives a lot of weightage also in the JAM examination. Uh, so this will definitely help you. So f double dash at 1 is equal to 1. Or maybe f dash at any point you can easily calculate if you know f double dash x in general. Okay, so here maybe I'll share these notes with you. So here I have given a LaTeX solution of this. Okay, so now here this is similar with the what we have already done, this Leibniz rule. So what will be the derivative of this? F dash x. Now one line answer we will write down. So can anybody help me out to complete this solution? Because this is my hx, this is my gx, and this is my f of t. So how will I calculate? So basically f evaluated at gx into derivative of gx minus f evaluated at hx into derivative of hx. So it is basically cos. Okay. So I'll use this is similarly. This is f evaluated at gx. So gx is x square into derivative of x square, that is 2x, minus f evaluated at hx. Hx is sin x into derivative of sin x. Derivative of sin x is basically cos x. And now what is f at x square? My f of t is basically cos of t square. So f of x square will be
Cos
cos
it.
of x raised to 4, correct? Into 2x minus, this is f of t is cos t square. So f of sin x will be cos of sin square x into cos x. So this is my final answer. So it is 2 times x cos of x power 4 minus cos x into cos of sin square x. Okay. So let's see this. Yeah, you can see this, which I have written say. Yeah. No, this is again similar type questions. F of x is equal to sine of t square. So f dash x will be straight away. It will be sine, instead of this, it will be, can anyone quickly?
Sin x to the power 4 into 2x.
Very good. Good. Yeah. 2x into sine x power 4. Now here, instead of find g dash x, I'll ask find g dash at 0. So let's try out. I'll wait for some time. Find g dash at 0. And the hint is use the Leibniz rule. So this is my h. This is my g. And this is my f of t. So f is continuous and these two functions h and g are differentiable. So we can apply the fundamental theorem of integral calculus. So what will be the g dash x? It will be f evaluated at g of x into g dash x. G dash x means one का derivative is 0 basically, minus f evaluated at sin x into derivative of sin x is cos x. So I know my f of t is basically e power t square. So this is this. So I will only left with my f of sin x cos x. Now what is f of sin x? Minus f of t is equal to e power t square. So it will be e power sin square x into cos x. Right? So what will be g dash x? I got this minus e power sin square x into cos x. So what will be g dash at 0? It will be minus e power sin square 0 into cos 0. What is sin 0? Sin 0 is 0. So you will have minus e power 0 and cos 0 is 1. And e power 0 is 1. So final answer is minus 1. So g dash at 0 is basically minus 1. Okay. Yeah, maybe I have calculated g dash x, but then you can see that from this you can easily get g dash 0. Maybe there are 2 more problems. So I have tried to cover 10 problems. So now can you answer this quickly? H dash x orally? It is basically you substitute x square. Substitute instead of t, you type x square here, write x square and take the derivative of x square minus now lower limit, that is x. So it is ln of 1 plus, instead of t, we will write down x square. So it is x power 4 into derivative of x square is 2x minus now lower limit, it is ln of 1 plus x square. Is it okay? Into derivative of x is 1. That is very important. So it is ln 1 plus x square into 2x minus ln 1 plus x square. Yeah, so maybe 2x I have written it. This 2x we have written at ahead. So 2x ln of 1 plus x power 4 minus 1 plus x square. Yeah, find f dash x. This is the last problem, maybe a second last problem.
Sir, can you show me the question number 8 again? Okay, sir. Thank you.
Okay. Now can you solve the question number 9?
So it will be 1, sir.
It will be 1. Very good. So f dash x will be, it will be 1 upon now 1 plus tan square x into derivative of tan x. What is derivative of tan x? It is x square x. And now when you substitute 1, so it will be 1 upon 1 plus 1 square into derivative of 1 is 0. And 1 plus tan square and sec. So this is basically sec square upon sec square x. So it will basically give you 1. Correct. And this is the last problem. Yeah. So I'm sure that now no need of, you can easily answer this. It is basically cos cube x into derivative of cos x, that is minus sin x. Oh, yeah. Is this okay? And then this, I'll just quickly state what is second fundamental theorem of integral calculus. So it says that if f is continuous on closed interval a comma b, and f is antiderivative here, the antiderivative world. So what is the definition of antiderivative? Capital F is said to be antiderivative of f if f dash x is equal to f. Then the integral a to b small f of x dx is equal to f of b minus f of a. So basically f evaluated only at endpoint. So what are the application of this? It's evaluate definite integral quickly using antiderivative. It connects the derivative and integral and differentiation without variable limits. Or maybe you can use chain rule or Leibniz rule. And this is a small formula. Sometimes people may ask, find out the average value. So you can find out f average is basically 1 upon b minus a integral a to b f of x dx. So here is one question which was basically based on the second fundamental theorem of integral calculus and was asked in the 2018, which says that if you have f of x is equal to 0 to x e power minus t square dt, find the derivative integral of f dash x, right? So can you tell me what is f dash x here? Or maybe you can see that this is basically 0 to 1. This f dash x is this fx. You could see that this f dash x can be written as 0 to 1 dy dx of fx. Now, if you look at the second fundamental theorem of integral calculus, what it says, so integral a to b. Now, what is my fx? My fx is basically f dash. So so instead of fx, I can write down f dash x, and the derivative integral of f dash x is basically f of b minus f of a. Right. So basically, the antiderivative evaluated at b and antiderivative evaluated a. Now here on the same line, you could see that you have to find out f dash x. So basically, this is basically f at 1 minus f at 0 by second fundamental theorem of integral calculus. And what is my f at 1? You can calculate f at 1. Similarly, you can calculate f at 0. F of 0 is 0 because integral 0 to 0. So it is f of 1. And f of 1 will be 0 to 1 e power minus t square dt. Maybe you can keep this as it is because this needs some higher integration results to find out this answer. Well, this was just 1 to 3 f of x dx is equal to 3a. So 3 to 1, you just have to reverse this. I just found you can reverse the limits. So you should also know the basic rule of integration, like integral a to a f of x dx is always 0. Then integral a to b f of x is also equal to minus b to a f of x dx, so on and so forth. And further additive property and then multiplication property, or maybe division and all this you should know. Here's a quick revision what we have done so far. This is very important formula. If you know this formula, you can easily solve, orally you can solve the problem based on the fundamental theorem of integral calculus. And the second fundamental theorem of integral calculus formula we have seen. And these are small references, some references which we had. One should use reference books for fundamental theorem of calculus. So this is very good book. That's Thomas Calculus. You can go through this book. Particularly, there's a chapter called as a definite integral and all that you can go through. Then there is a calculus by James Stewart's, which include conceptual explanation, solve examples, and IIT jam level exercises. And this is also one of the nice book authored by Indian author S.C. Malik and Arora. And this gives a rigorous proof of the fundamental theorem of integral calculus. The proofs are also proofs are not difficult. One can go, interested users, readers may go through the proof. It's easy proof. And to understand the concept of differentiability and integration, one must read the Bartle and Shepard. And there's one more book. This is by Mathematical Analysis by Tom Apostol. Another publication. That's it. Thank you from my side. If there is any question, you can ask.
Thank you, Prakash sir. If the participants have any doubts or queries, the floor is open.
Okay, then I hope audience have understood this. If there is any question, you can always write to me. Maybe I can, Prathamesh, you can share my email ID. If anybody has any doubt, they can contact me through email.
Yeah, sure, sir.
Thank you.
Thank you, sir. We have now come to a close on sir's first session today. We are deeply honored again to have you as a resource person. We are looking forward to your sessions in the coming week. So the next session would be on 27th October, which is Monday, from 11 to 12, the same time.
Okay. So I'll try to cover the Riemann integration parts and then L hospital and all. Yeah. So we'll see that. Okay.
All right, sir. Thank you so much. Thank you, participants. Thank you very much.
Thank you, sir.